Okie dokie. Question 5.3. Right. So this is a bit like question 5.1, except we are now explicitly using an exponential population growth equation. Okay. So this is what I'm looking at. See that? Nt equals n naught e to the lambda t. So I'm basically saying in this question, okay, let's read the question. A population of wild mink on a river system increases from 2,500, that's n naught, to 4,250, that's nt equals 8, right? So to 4,250 in 8 years, so t is equal to 8. I'm asking you to calculate what the population at the end of the first year, t equals 1, and the second year, t equals 2. And then I'm asking you how long will it take for the original population, so that's n naught, that's 2,500, to double. And I've said explicitly that this population increase is described by the relationship nt is equal to n naught e to the lambda t, where lambda is some growth rate, okay? It's a constant. So where shall I start? Okay, let's go over here. Where's my one note? There it is. Okay, so let's just write that equation down a second. Nt is equal to n naught e lambda t. What am I trying to calculate? Well, initially I'm trying to calculate how much, how many are there at t equals 1, right? I know this. I know the time. I don't know this, which means I can't know this. So I need to calculate lambda first, okay? So I need to know this value in order to calculate this value at any given t, okay? So let's calculate lambda. Now, how do I do that? How do I get lambda on its own so I can solve it? At the moment, it's an exponent of this e. So e is a funny number. It's a constant in nature. It's got a value of about 2.71, but I can get rid of it and I can get that exponent down in line where I can solve if I apply a natural log to both sides of this equation. Okay, so remember what the natural log is? It's log to the base e, or ln. Okay, so I'm going to take ln of both sides first. Okay, so I'm going to do ln of n t is equal to ln, I'm just going to slam it all in brackets, e to lambda t. Okay, let's expand that. Now I can't really do much with the left hand side here. It's going to stay as it is, but my right hand side I can use, because this is a multiplying, these two terms are multiplying. I can expand those out using my addition rule, plus ln e to the lambda t. Now ln of e of x is equal to x, right? You happy with that? I've used the first rule, take the x down there, so x ln e, and ln e is equal to 1. Okay, so let's rewrite this. Ln nt is equal to ln n0, and then if this was x, that would mean that this is simply lambda t. Okay, let's solve this for lambda. I can rewrite this. I can take the ln n0 over to this side. Ln nt minus ln n0. And then I can divide the whole thing by 1 over t. Okay, and I've just taken the t over as well and divided. Right. I can simplify this a bit further if I wanted to. That's my subtraction rule. I could rewrite this as okay, so I can now solve that. I can solve for lambda now, because I can take my n naught value. Remember what n naught was? Let me just figure that out. N naught was 2,500. Okay, and I've also told you that nt is equal to 4,250 at t is equal to 8 months. So I can plug all of this in. ln 4,250 over 2,500 all over 8, and I get a value here for lambda of 0.0663 to 3 sig fig. Okay, so I've calculated lambda. I can now, actually, what you should do is you should check that value, right? So let's do a quick check. So if you want to check your lambda values right, let's plug it back into the equation. If it's correct, n naught e to the lambda t is equal to 2,500 e 0.0663 times 8. That should give me a value of 4,250. Actually gives me a value of 4,249, which is 4,250 to 3 sig fig. So I know that this value here is correct. Okay, always do a check. We all make silly mistakes sometimes. If you check it and it's wrong, you just do the calculation again, and you don't want to lose marks that way. Okay. Right. Next, the question was asking us to calculate the population after a single year. So that's at n t equals 1. Now I'm just going to plug the values in. So my n naught is still the same, it's still 2,500. My e value now is 0.0663 times 1. I'm just going to leave it there. Okay, that gives me a value of 2,671. And after 2 years, that's n at t equals 2. Again, that's 2,500 e to the 0.0663. This time it's times 2 in the exponent. Okay, that gives me a value of 2,008,000. Keep going. 2,854. Okay, so that's after 1 year. That's after 2 years. Okay, and the last part of the question was, how long does it take for initial population in other words, n naught, to double? Right. Well, let's think about that. So I'm asking for a value of nt, which is double the initial 2,500 times 2, which of course is equal to 5,000. So I'm now going to solve nt equals n naught e to the lambda t for t, and I'm going to find out what time it takes for nt to get to 5,000, still with the n0 of 2,500, and with my lambda value that I've calculated. The lambda value is 0.0663. Okay, so let's solve this. Let's rewrite this for t. I've already done a lot of the hard work above in the very first part of the question. When I was calculating lambda, I got this far. Over n naught equals lambda t. So this, and that's when I was working out lambda. Now I'm working out t. So actually, this time t is equal to n t over n naught. times by 1 over lambda. Okay. NT over N naught is 2. Okay. NT over N naught is the ratio of the population at time t to the population at time 0. It's doubling, so it's 2. So ln of 2 divided by 0.0663, that gives me a value of 10.45 years, or 10.5 years, 3 sig fig. Okay. Any questions? Let me know on Teams. It's very likely you're going to get a question like that on a test or an exam. Okay.